So I've just done an introduction onto what this webinar is about. And just once more, just as I mentioned, this is the third part in a series of performance webinars. So each week on Monday, another part will be broadcast, and later we'll upload that to our YouTube channel, which is C2B2 Consulting. So here's where we are today, part 3. So don't forget to register for our other upcoming webinars. We've got another 3 on Oracle Service Bus, BPEL Performance, and Oracle Enterprise Manager. Those are the dates, those are the times. Please do register for those, and you'll be reminded when they come along. So our agenda for today is with a view on WebLogic. We'll be looking at causes of performance issues for WebLogic, and we'll recap some of the details that we saw in week 1 of this webinar series. Secondly, we'll look at the diagnosis in WebLogic. So we'll recap some of the JVM tools which Matt said in the second week, which was last week. And we'll also look at a few WebLogic specific tools that we can use in diagnosing these performance issues. And finally, remedies, we'll look at areas that we can focus our tuning effort on and how we can scale WebLogic. So in week 1, we heard Steve talk about the causes of performance degradation. Now, resource contention does require careful tuning, as obviously you can't scale your way out of this sort of problem. That's more of an architecture and system design issue, and something that you might want to look into your applications design to solve. Resource limitations, now that can be addressed with tuning and the ability to scale yourself out of the problem. And if you can't scale, you'll find that you will hit a wall. There's only so much you can tune out of the system. And thirdly, we've got latency, which is the time delay between requesting an operation and the operation actually being initiated when it starts to be processed. It's a very key factor in large-scale SOA applications, typically not taken into account during development. And this is a list of some of the things that Steve went through as a major cause of latency. This is something that you can address when you are in your application design phase, and as a review of your applications as well. We also looked at this diagram. Now, Steve's webinar concentrated on the concepts shown here and the phases of this tuning process from a general standpoint, covering the principles that guide these processes. Matt's follow-up last week concentrated on the Java JVM specific aspects of that process, all the different phases and how you can make JVM specific changes and use tools to help in the analysis phase. And the rest of this webinar, we're going to focus primarily on the analyze and change phases of this diagram, but we're going to be looking at it from a specifically WebLogic standpoint rather than the more generic principles standpoint or the Java JVM standpoint. So firstly, we're going to be looking at analyzing a WebLogic environment, and I'll recap the tools that come with Java, which I mentioned in more detail by Matt last week, but how these can also be used for WebLogic just as much as any other JVM-based application or server. And moving on, I'll give an overview of how JRocket can be used with WebLogic. You do get a JVM JRocket license in with WebLogic, and it is now free for non-commercial use as well and development use. And it is a really handy tool to use, so that's really something that I would encourage you to download yourself. It's a free download, as I've said, for development use and testing, and you'll be able to use that and see how it works yourself. It's a very interesting thing to look into. And finally, we'll be looking at the WebLogic Diagnostic framework, which if you do already use WebLogic, which I assume most people who are listening to this talk would be, This is just a useful web-based way of monitoring servers and applications. Now, it might be something that you've come across before, might be something that you've seen but never particularly used before, but we'll be looking at how that's quite useful in monitoring some of the things that you can come across. So firstly, we'll look at the OpenJDK or Sun provided tools. Now I say Sun, that's obviously WebLogic Oracle now since the takeover, but it is a JDK that originated from Sun. So now to get live information from the JVM, so what's actually going on a production system that's working at the moment, Matt showed us some tools last week which can provide data in different ways. So we've got JStat, which is a command line JVM tool, and it prints stats which are related to a number of JVM functions. GC cores and GC are some very useful options. There's JStack, which produces thread dumps and stack traces for all threads that are running at the moment, and shows detailed locking information with the -L flag, and that's also a command line tool. And lastly, there's Visual VM, which is a visual GC plugin, and does also give you some threading views. It's very useful. The fact that it is graphical as well means that you can look at the data in a very easy to analyze way without having to put it through a secondary tool. Now, if you're recovering from an outage, you'll be less interested in live data because that will be post-outage and irrelevant to the problem. What you'll need to focus on then is analyzing historical data for trends to see what was happening at the time of the outage. So now verbose GC, now this is just a JVM flag which enables very lightweight logging of GC activity. And the reason why it is so lightweight is that all the activity required to generate the information happens whether the flag is on or off. Turning it on simply saves that activity. It's so lightweight that it can be used in production with what can only be described as negligible impact. It really is something that is recommended to keep on at all times. It makes such a tiny impact that the good far outweighs the bad. Also, you wanted to look at heap dumps. Now, heap dumps will show you what was happening at the time of the outage, and there are two different things here that I've outlined. There's the hprof heap profiler. Now, this is just a simple profiler agent that's shipped with JDK 5 and up, and it writes out profiling information either to a file or to a socket in ASCII or binary format. Now that information can be further processed by a sort of front-end tool. IBM's memory analyzer can do it. There are other ones available as well. But hprof is capable of presenting CPU usage, heap allocation statistics, and monitor contention profiles. It can also output complete heap dumps and report the states of all the monitors and the threads in the Java virtual machine. That's useful when you're analyzing performance, lock contention, memory leaks, and a whole host of other issues. Along with that, there's also the heap analysis tool. Now this helps debug unintentional object retention. Now that phrase, unintentional object retention, is used to describe an object that is no longer needed but is kept alive due to some references through some path from a live object. That's what we call a hard reference rather than a soft reference, which is a terminology you might be more useful with. So now that provides a sort of convenient means to browse the object topology in a heap snapshot that's generated using the hprof. The tool allows a number of queries, including show me all reference paths from the root set to this object, and that will just give you a way to have a look at how your application is holding on to some references that it perhaps doesn't need to, and there's plenty of information on the internet about how to go into your own applications and change hard references to soft where they're not needed. So that was a bit of a brief recap of some of the things that we've covered in the last 2 weeks. If that's whet your appetite, I really would encourage you at this point to visit our YouTube channel, rewatch some of the videos that have been there. Both Matt and Steve are really good at this sort of thing, so I personally found them both very interesting anyway. So now we'll move on to JRocket. Now this is really from much more of a WebLogic focused perspective, although JRocket is just a JVM, the same as Hotspot, and the JRocket JDK tools, just as the Hotspot tools, can be used for any Java process, so can JRocket. So this is the JRocket Mission Control. Now Mission Control is one tool, but it's really made up of 3 tools. The console, which is the view that we can see in this screenshot here, the flight recorder, and the memory leak analyzer. So first we'll take a look at the console, which is pictured here. In the first view we've got the General tab. You can see there's these 4 tabs here, and we start off in General. This is just a system overview to give you a quick view of the health of the heap, how much CPU usage is going on. So we can see this is using half of a very small heap, using very little of the CPU. The system isn't really doing very much at all in this screenshot. Next we've got the MBeans view. Now all of the MBeans that are exposed by WebLogic and by any sort of JMX process really in JRocket can be monitored to some degree. It's not what I'd call quite as full-featured as a proper monitoring tool, but it's better than nothing if it's all you've got, and you can either browse MBeans or you can set triggers on them. This is a picture of the triggers page, and you can see highlighted is deadlock threads and thread stack dump. So when it's basically a way to set the JVM to fire off an event every time there's deadlock threads, do a thread stack dump. This is the runtime tab. This just gives you live metrics. You can see each of the threads and the stack trace for those threads that are running at the moment, whether they're active, stuck, or blocked, or whatever. We can see that instantly here. And the advanced view, this is just one of the things that you can do with the advanced view. You can profile methods, but this is a picture of the diagnostic commands view, where you can execute any command line function that you want on the server. Now, the reason why this is useful is that we can see over here on the left we're connected to this 1.6 WebLogic Serve, which is, you can see in this tab here, this is the process 17515 that we connected to. This is a local instance, but we can also connect to remote instances. So this feature of being able to run commands does get very useful with remote access. Next we'll move on to the memory leak detector. And this basically shows an overall trend, which is the growth rate of each type, which is shown rather than just the percentage of the heat that they take up. It stops common classes from showing at the top, like character arrays. We get a visual representation of hot objects in the heap, and that can be either by type or by instance. So by type you can see how each class is referenced by other classes, and by instance you can see how each instance of that class is referenced, meaning that you can include not only those instances from your application, but those instances that are also used by the system, and you can make that, and you can see that difference quite easily in the tool. And finally, it also shows where objects are allocated. So in other words, you can see the stack trace for each method holding an instance of the of whatever type, and what percentage of those instances are held by each method. Now we'll just go through some screenshots. I realise that's quite a difficult thing to hold in your head while I'm just describing it, so I'll go through some screenshots which demonstrate those different aspects. So here we can see the overall trend view. Now you can see there's the growth rate column and the delta count column. Now you might be able to see that at the top this sort of gets a slightly darker pink and it's quite light towards the bottom. Now the higher that delta count, which means the increase or decrease in the number of types that are appearing. So we've got 1316 instances of the object class, and that's since the last time the measurement was taken, so that's quite a big increase there, and that's why it's quite a dark pink color. Now that does, if you were to scroll down in that picture, you would see that some of them would be blue, so when garbage collection happens that delta is negative, and the heap is shrank with those class types. Here we can see a graph of the information that we've just looked at. So you might be able to just make out that the hash map class here is blue, so the amount of hash map instances has decreased on the heap, and we've got 4 slightly redder classes which have increased the number of instances, and the other white ones, you see, they've stayed the same because they're just white and the color is unchanged. So next we'll move on to the flight recorder. This was formerly called the JRA recorder for those of you that are used to JRocket in times of old. So this was originally called JRocket Runtime Analyzer, but since more features have been added, Oracle have rebranded it to reflect the upgrades and that it does more than just that. Now it does provide similar data to the console view, but this does come with a crucial exception. It gives you historical data, which enables you to do post-incident investigation and to review any periods of poor performance. So as I mentioned earlier, when I covered the JVM tools, it provides in the JVM some tools to look at live data and also historical data which you'd want after an outage, or to review any periods of poor performance. And this is the JRocket equivalent. Flight Recorder will give you this historical look. So now let's look at the WebLogic Diagnostic framework. So the WLDF framework allows monitoring of MBean metrics. These are any MBeans that are exposed by WebLogic, and it also counts for OSB things deployed to WebLogic, and it's quite configurable as well. There's a link on the console homepage to what's called Monitoring Dashboard. You won't see it actually labelled as WLDF, but once you open that, you'll get a list of some default views which look like this. And you can see there's the JMS runtime, JVM runtime heap, and thread pool runtime. Now these are built-in views. These are ones that will be there with any installation of WebLogic, and we can see that the pictures there are coloured in. Now that means that the recording has begun. You can see that you just click the play button to start recording, and on the picture to the right the play button has been greyed out, so it's not green like that little icon, and that means that recording started on all 3 of those pictures there. And in this next view you can see what it looks like when one of those isn't recording. The JMS runtime, the icon is greyed out, so that's not recording, but the other 2 are recording. So this is a view of the sort of data that you can collect from these built-in views. You can see that there's this pencil icon on the blue bar to the right, which allows you to edit that graph. You can add other things to it, take things away that you're not interested in, and really make it useful to you. Everything is very, very configurable. So here, this is a view of mbeans that have been collected on a servlet. Now, servlet metrics do need to be enabled explicitly for your applications. And if you look on the console homepage, on the left-hand side, there's a diagnostics link. Underneath that, there's diagnostics modules. And there you can configure and create a new module to monitor your application. And when you do that, it will need to monitor the servlet runtime mbean. And that will show, as you create that, that will show a list of collectible metrics. And in this screenshot, this is what you will see after you've created that module. You can browse some of the metrics that you've selected to be collected. I have already pressed play to start recording on that module, and I've ticked this box to only show collected metrics. And you can see in this bottom left-hand pane, we've got 7 metrics there that we're measuring. And on the right here, there's the graph showing the increase in the execution time total metric. So that's the WLDF, and as I've said, that is very configurable. But once you've looked at the diagnostics framework, you've seen all your metrics. As Steve was saying, you don't change things based on a whim. You change things based on metrics, based on data that you can prove something's going wrong. We need to find a solution to the data after we've done the analysis. So there can either be a software solution or a hardware solution, really. Software solution is mostly going to be concerned with tuning options. These are going to be your small, quite incremental, quite rapid changes that you can put into a staging environment, for instance. It doesn't take very much to make a change, analyze it to see how it's affected performance in a staging environment, and then roll that change out to production. It's a fairly quick process compared to hardware solutions. And it is also very good to remember to only make one change at a time, and get that one change taken right through the lifestyle, so that it's come from inception to either rolling into production or throwing away before you move on to another one. So the hardware solution, that's going to be scaling options, which is going to be a long-term project, really. Any changes are going to be implemented based on research evidence, and they're going to need to be justifiable as well, because that does incur a cost. Now, as far as tuning goes, you can tune your WebLogic environment, and it is very much like this image here. We don't actually change any of the mechanisms of WebLogic. We just change them to fit the use case that we want. You can see there in the picture the car's quite a high performance one, so everything will be tuned to give the most throughput of fuel, and for that car to operate at a very, very high revolutions per minute, for instance. And that's a good analogy for WebLogic. You need to understand how it's going to be used before you make changes to anything. Obviously, any best practice is only best practice when considered in relation to what you're going to be using your server for. So the first one really is architecture. Things that you might want to consider with architecture is whether you are running a basic or a multi-tiered architecture. Basic is usually preferred for performance, because with multi-tiered, the first thing you'd want to separate off into a tier is your object layer, which holds a lot of the data. So doing the communications there on a multi-tiered architecture, that's going to introduce network latency, which Steve covered before as a big cause for performance slowdown. trying to access those objects is going to involve RMI calls, which can be inefficient at large volumes. It's much more performant to keep everything in the same place, keep everything as close as possible in terms of network distance. As fewer network hops as possible is what you want to aim for with your architecture. But then obviously that does need to be played off against security. If you do want an extra layer of security, adding a firewall in between those tiers, then you might not be able to escape going for a multi-tiered architecture. JDBC. This is something where you'll want to be looking at the number of connections that you are making and destroying. Actually making a JDBC connection, very often your database is remote. It's not a local thing to the server that it's running on. This is going to introduce network latency, creating and destroying connections. It uses up performance cycles, CPU cycles, when you have to create a connection or destroy one. It's much better to hold the creation pool, the connection pool, at as high a value as you can. So you'll want to be setting your initial value of open connections to the same as your maximum value. If that's not something that you are capable of doing with your hardware, then that's really something that you're going to need to look at increasing the scale of your hardware and adding more resources. If you think of a use case where your initial connection pool is 5 and your maximum is 500, you might find that if that's your range of connections being held open, a lot of the time is going to be spent with WebLogic trying to optimize that and trying to keep the number of connections low in the pool, but then having to ramp that up when performance needs start to increase. Next we've got JMS. JMS is quite well implemented with WebLogic. It has concepts of distributed queues, where you can load balance across multiple queues and multiple JMS servers, and you would have to disable server affinity for that to enable the producer to effectively load balance. So obviously server affinity just means that once it's made that connection, it sticks with that server. Disabling that does mean that you can have any server deal with any JMS message that that your producer might send, and if you can have some influence over your application design, it's best to make any of those operations idempotent, so that having to re-execute any of those operations that might be executed over JMS won't have any adverse effect on your system. Next we've got work managers. If you're unfamiliar with work managers and you work with WebLogic, I would suggest that you certainly make it a priority to research work managers. These are basically thread pool managers. You can set these up to manage the amount of threads dedicated to various different parts of work in your system, and it's certainly something that any business should be making use of that uses WebLogic. And finally, coherence, or just a data grid in general, really does help out with performance for the web tier in your architecture. It'll help out by storing HTTP session data and distributing data. Obviously, being a data grid, it enables you to cache things that you use very regularly and eliminate more expensive database transactions. Next, in terms of scaling, we've got options of scaling up, which you might know as vertical scaling, or scaling out, which you might know as horizontal scaling. Now this is for after you've tuned your WebLogic server as much as you can, and you think, okay, I've got as much performance out of it as I possibly can, but this still it's not giving me enough. You might want to either scale up, which is going to entail adding more application servers to your physical hardware, or scaling out by adding more physical hardware, and thereby increasing the number of servers that you've got. So from a WebLogic perspective, yes, so you can see that just got the explanations there, adding more servers or adding more physical hardware. So from a WebLogic perspective, we might start out with a very basic load balancer here, which isn't actually doing any load balancing. It's in that picture, it's acting as a single for a single host and a single server system. It's not actually balancing, it's just acting as a proxy for the web layer. So if you wanted to scale that very basic system out with just one managed server, we can scale out by adding another physical host. Sorry, we can scale out by adding more physical hardware. So now we've got our original managed server on host A, which is our first bit of physical hardware. Second bit of physical hardware is host B, and that's got our managed server 2 on it. Now actually in practice this might be a physical box, or it might just be another virtualized instance. Either way, the concept is the same. You're adding more resources in the form of, from WebLogic's perspective, a new system. Next, if you just noticed, we've now increased to 4 managed servers. We've got 2 on host A and 2 on host B. That's going to be scaling up. We're increasing the number of servers per host. And obviously when making the decision about whether to scale up or out, the key influence is more than likely going to be infrastructure and budget limitations rather than performance considerations, unfortunately. It's the world we live in. Things need to be approved. Financials do need to be taken into account. And commonly the decision to scale up, the decision to scale out by adding more physical machines will come after you've already scaled up your environment to maximize the usage of the current hardware. So you can add as many managed servers to your physical host as you can to make sure that all of your RAM's being used, all of your CPU cycles are being used. There's no waste there before you add more hardware, which just makes sense. If your hardware already has enough application servers to maximize use of its resources, and after tuning you're still finding you've got performance problems and slowdowns, the solution is invariably to just buy more kit. So all that remains is to thank you all for listening. Apologies once again for the slight technical difficulties at the start of the broadcast, but I hope you got what you wanted out of the main body of this presentation. Either way, your feedback is very valuable to us. And don't forget to register for our other 3 upcoming webinars, or keep an eye out on our YouTube channel for more that we upload. Once again, thank you for listening, and we expect to see you again next week, next Monday at 5 o'clock.